Welcome to the project demonstration of dual frequency based single phase inverter using PIC microcontroller. So in this project we are going to design the two inverters with the two dual frequencies and to control the main AC output load, and the frequency will be displayed on this screen. So coming to this main base paper application. So here it is a main paper of the project. So here we are going to design this power inverter and auxiliary inverter. This is the alternating power source for this load section. So this is the frequency based on this around 50 Hz, and this one is going to be the 120 Hz frequency will be generated by this processor. So here the processor we are going to make use of PIC microcontroller. So whenever the change of frequencies occur, that will be plotting in the MATLAB in this manner. So we are going to plot this waveform along with change of frequency. This only waveform we are going to plot in the MATLAB directly. And here the inputs are 50 Hz pulses given from the microcontroller and 120 Hz pulses given from the microcontroller with using the PWM signals to the MOSFET bridge. So here we have designed the MOSFET bridge as well as IGBT bridge. So this one is a main primary inverter with step-up transformer, as well as same signal will be given to the with 120 Hz frequency to this auxiliary inverter. So these two are the inverter sections controlled by this PIC microcontroller. And next, this one is the battery source for these two inverters, like one battery pack and another battery pack. So one battery pack consists of 4 volt 1 amp batteries are connected in series of 3 numbers. Then it's going to be the 12 volt 1 amp, and this also same 12 volt 1 amp. And coming to this battery is a rechargeable battery. Just 2 charges battery. Just we need to connect this cable to our 230 volts power source, and then it will take around 6 to 8 hours minimum. So just when you connect that, there will be light indication. The indicator is battery is getting charged. So we need to connect that battery at least of 6 to 8 hours maximum. Then only the battery will get fully charged. After that time, you can disconnect that. And then next, coming to this flow, 230 volts will be given to this transformer. So it will step down the 230 volts to 12 volts of AC voltage. And with the help of these 4 diodes, we are going to convert the 12 volts AC to pulsating DC of 12 volts. And with the help of this capacitor, we are going to remove the pulses, and then you will get the pure DC. And then parallelly we are going to indicate the status of the power availability from this transformer through this LED indicator. And there are the 2 diodes. The purpose is, if the battery will get fully charged, then it's going to be the high potential and the transformer is going to be the low potential. Then in order to protect the transformer from reverse flow, then we are going to making use of these diodes in forward bias. Then only the battery will get the supply from the transformer instead of sending back to the transformer. So this is all about the charging circuitry. And the battery ratings shall be discussed 12 volt 2 amps. And once we need to connect this to the B, small b to the small b, and here we have already connected that T to the T for the transformer section. And coming to this battery, this one is the B to the B. So these are the connections we need to make. And then after, when you connect this battery at this small b, then these 2 sections will get the 12 volts directly, and at the same time the microcontroller will start providing the 50 Hz pulses and 120 Hz pulses to these 2 inverter sections. And based on the pulses, we are going to step up in 2 ways. This one transformer is step up purpose, and this also one transformer is to step up purpose. The output is directly given to this load. So here the purpose is, whenever the voltage is low at the primary end, the voltage fluctuations are occurred, then in order to provide the auxiliary power, we are making use of this dual frequency alternating auxiliary inverter here. And the so-called frequencies and status will be displayed on the LCD screen, and also we are going to plot the waveforms of this change of frequency in MATLAB through this USB to TTL converter. So let us see the demonstration at this end initially. And when we connect this directly, we are going to get the load switching off, and also the frequency will be displayed after calculating the primary frequency and auxiliary frequency 50 and 120 Hz. And after switching on this gauge, just connect our USB to TTL converter to your laptop. Yes, I'm connecting through my USB hub. Right. So after connecting that, go to device manager So go to this PC. After connecting that, actually you need to install this application. We'll provide you the one more video how to install this PL2303 converter. So this is the application we need to install, and after installation it will ask for you insert the PL2303 module. And now after inserting that, go to device manager, manage on the right click on the this PC and go to device manager, and then there will be, we can see one ports section. So here we can get the COM3. If is there any yellow triangle or is there any other error message occurred, then disable your laptop Wi-Fi better and reinstall the application, and same go to this device manager section, and then we'll get the COM number is 13. Now note down the COM number and then open our MATLAB code. So this is our MATLAB code. Open this. So once you open the code, it will be redirected to the MATLAB. After installation of the MATLAB, it will open in the MATLAB section, and here we need to change the code only one line, that is line number 4 COM13. So in my case, in my laptop I got this COM13, but in your case it may changes the COM number. Check from the device manager and enter that COM number here, and after that just click on run. So once you click on the run, so you can see in the command window, so just battery is getting low, that's why I'm disconnect the bulb, and now you can see one data is sending to the laptop. It's blinking, and now just restart the microcontroller and then rerun the code. So there we can see the waveform is continuously plotting the frequency. At some time it will change, the frequency will be captured by the microcontroller, and we are plotting the voltage from 0 to 5 only. Actually this was 0 to 12 after the MOSFET, but I am plotting the frequency input which is providing to the microcontroller, from the microcontroller to the MOSFET boards. So somewhere it will plot the change of frequency. So once the plotting section was completed, it is starting from 0 again. So in order to do that, you can restart the microcontroller so that it will starting from the plotting will be coming from initial variable. Just I am restarted the microcontroller now. Right, so there is a change of frequency occurred. So if you didn't get the change of frequency because it's already happened, then you need to restart your microcontroller so that you get the proper directly. So then you can connect the load also, right? Because the battery is getting low, so it's going to be the dimming. You can remove that and keep the battery charging. Right, thank you.